So last year, as I mentioned, I did that presentation here at NoleCon. When I did the presentation really consisted of two different parts. The first part talked about the framework for an electric utility. What does an architecture look like? What are the different types of systems that you find inside of an electric utility? Okay, so I presented a whole bunch of different diagrams. If you want to learn a little bit more about the different types of systems that an electric utility has inside of it, it's a great presentation to go back and watch. The second half of the presentation, I went through and started talking about a penetration testing methodology that we can use to go through and do penetration testing. Because when we do penetration testing, if you work in any other type of field inside of IT, the skills that we have and the knowledge we have is applicable. However, we have to know how it applies. We have to know what we can do and what we can't do, what causes problems on these systems. Because when we work with control centers and control systems, they're very highly sensitive. And the wrong action doesn't simply cause the server to crash. The wrong action can shut down power for a city or for a nation, or cut off different manufacturing facilities inside of a plant and stop the manufacturing of a very expensive product line that can destroy financially various different companies. So we need to take a great amount of care with this, with doing penetration testings on these types of systems. The other thing that we have inside of our critical infrastructure, inside of the smart grid, is we have a lot of physical devices that are exposed, physical access, embedded devices that attackers can get their hands on and attack and leverage those devices or the communications to those devices to try to attack the organization itself, the utility where all the large, high sensitive systems are. So when we have a penetration testing methodology, we need to consider all these various different facts, the different types of systems we need to test, the different types of methodologies and skill sets that we need to perform this penetration testing. Now, attacks on energy are not new. This is one of my favorite pictures. This is a diagram of basic energy theft. People for years, ever since we've had electricity, have been stealing electricity from electric utilities. This is one of the most basic attacks where they have the meter that's plugged into the facility. All you have to do is pull the meter out and then bypass them, make permanent connections of metal to be able to connect where that meter originally spanned, to be able to get free electricity and no longer have a meter spanning it. So that's what this diagram shows, is how people have simply done this, put the little jumpers in, and are now stealing electricity, and that's not being leveraged. But this is basic attacks. This is things that we've done for hundreds of years. With these new technologies, we now have more advanced technological attacks that perform this same function. And not just do it for theft and for fraud, but it also will do it for being able to try to cause reactions or cause actions that happen at a very large scale, whether those are going to be terrorist activities or whether they're going to be trying to gain some type of financial benefit from those attacks. So when we have penetration testing, ultimately what we're trying to do when we're working with these systems are we are attacking or we're trying to test finding vulnerabilities in control systems. Now this is a very generic architecture for a control system. Anytime you have a control system, whether it be inside of an electric utility, inside of a gas or hydro generation plant, or whether it be industrial control systems on a manufacturing floor, you're always going to have some type of a master server that's coordinating and controlling those machines. It's the one that actually receives all the information from the sensors. It's the one that sends all the control signals out, and it's the one that usually has most of the control engineers and operators authenticating to it to gain access to that functionality. On the other end of the spectrum, we always have various different types of field devices that are deployed, in the case of an electric utility, out to substations around the region, or in the case of a manufacturing floor, different types of manufacturing floor devices that have been placed out inside of the floor. Okay? More endpoints that are out there. In all these cases, these equipment that we're putting out, they're no longer safe, they're no longer secured and locked into our data centers behind closed locked doors. They are available where people can gain physical access to them and can try to attack those devices, pull information off those devices. We want to do penetration testing of this whole system from end to end. We want to test from the servers all the way down to these endpoint devices, these field devices. Because while these field devices, while they are susceptible and people have physical access to them, We know that if people physically touch the device, that they can be compromised. We understood this for years inside of computers. If an attacker gets their hands physically on your computer, you should assume that computer is compromised. Okay? There may be some data on there that's been encrypted that may or may not be compromised. The username and password or the security keys or anything to do with crypto off of one, you have high probabilities that it's actually applicable to everything else inside of the infrastructure. Another thing that we want to do when we do these penetration testing is we have these field devices. We need to start taking them apart. We need to start looking at them. So when we have a penetration testing methodology, we need to have a methodology that goes in and talks about how to work with embedded hardware. That's the part of the methodology that I presented last year, and I showed you a couple different types of attacks last year during the presentation. One of the things that we're doing today, and the reason why I'm here, is talking about this new tool that we're releasing, open source to the world, is SamuraiSTFU, the security testing framework for utilities. Okay, and I'll talk a little bit more about that as we go along. But this distribution, this framework for doing penetration testing, allows you not only to have a methodology, but gives you tools to go through and do different types of attacks and testing on systems like embedded systems. Many of us have used tools like Backtrack. Backtrack is an excellent tool for pen testing networks. But Backtrack often has very limited capabilities when you start stepping away from traditional IT. This is where this distribution is trying to come into effect and trying to be of help, is trying to help the special edge cases that we always deal with inside of control systems. So we worry about going through and having tools that help us talk to the microcontroller that's on this board. Okay? Different types of JTAG tools that allow you to talk to that microcontroller. Tools to be able to go through and talk to the individual chips themselves and to speak the serial protocols that the integrated circuits speak, like I2C and SPI. Okay? Not only do we have these tools inside of the distribution, but we also are trying to get documentation and information in there to try to help people understand. So I give you a tool that speaks I2C. However, to speak I2C, you still have to understand what types of messages you can send and receive. So we try to provide additional documentation, which is an ongoing process. We're trying to get into the distribution. Information like this basic explanation of how the I2C protocol works and how you actually build the messages. We also have tools in there to be able to do things like bus snooping on these embedded devices, trying to capture data and capture communications floating between the multiple different electronic components on a circuit board. Very similar to how you capture it off of a network, a normal IT network off of Ethernet. We can do very similar techniques with specialized hardwares and the right tools to be able to pull this information off of the circuit boards themselves. Doing different things like disassembling code. When we have embedded firmware that's using assemblers that are often very different from the assemblers we have in traditional systems, try to provide some type of a feature or tools available to give us some guidance on working with these different firmware devices. Another set of tools that we have are working with wireless. Most of us are very used to working with tools like Kismet or Aircrack NG, different tools that help us working with Wi-Fi, because as penetration testers and security professionals, we're always dealing with the Wi-Fi and the common wireless technologies that we have inside of IT networks. However, inside of control systems and control networks, especially inside of the electric utilities, we have a lot of wireless protocols that are custom. A lot of wireless protocols that might be standards-based, but they're standards that security professionals haven't created any security tools for. So needing to have some good tools to be able to work with these custom protocols like GNU Radio and GNU Companion, okay? And be able to try to provide some different types of block diagrams trying to work with some of these different protocols that you might come across and find inside of these systems. We also end up needing to, when we do penetration testing on control networks, work with specialized protocols. Here's just a list of some of the more common protocols we have inside of the control center world. So one of the goals of our distribution is trying to provide different tools to work with each one of these protocols. Okay? Trying to provide fuzzers and fuzzers already set up to work with some of these different protocols, documentation, links to additional information, and most importantly, when available, trying to find different types of simulators to be able to simulate these protocols so that way we can work on using our tools and testing our tools against the simulators before we go in and start trying to test them inside of real production networks. We also try to provide contextual information for security professionals that may be new to working inside of control centers. Okay? Inside of the control networks, we have highly sensitive systems, as I had mentioned. A lot of these systems don't hold up to traditional testing. They don't even hold up to traditional IT queries and finding out what's there. Doing a basic Nmap scan, unfortunately, still knocks over many of these control systems, especially the older ones. Okay, so we try to provide some contextual knowledge. Like here's a little hint for what are some of the do's and don'ts that you should do if you ever need to do port scanning inside of the control network. Like never doing any type of OS fingerprinting. Making sure you're slowing down your port scans so that you're not sending too many packets to a single host at a given time. Trying to avoid sending empty UDP packets because some of the protocols inside of the control center, many of them run on UDP, often don't understand if you send a UDP request to it and there's no payload, kind of like how Nmap always sends the UDP scans, it freaks out. It doesn't understand what's going on and it might crash. Okay, so giving that type of advice and giving the warning, service fingerprinting usually works, but be careful with it. So these are different types of advice that we're trying to do. Also, when you do things like vulnerability scans, having different types of tools like the Nessus scan policy from Digital Bond. Okay, this is a special policy for Nessus that you should use against any type of a control system network. What it does is it tells Nessus not to go through and do its normal tests trying to find vulnerabilities through unauthenticated means. It uses authentication inside of Nessus policies, disables most of the security checks that Nessus does, and tries to do everything through that authentication link. In the IT world, we see this as a great capability doing authenticated scans, but we always see it as kind of half the picture. Well, what happens if there's more vulnerabilities you can't see authenticated? Okay, it gives us more information authenticated. But inside of the control center world, running unauthenticated scans and doing all the different checks is a sure way to be able to crash multiple systems inside of the infrastructure. And sometimes not just crash, but permanently brick, requiring being sent back to the vendor themselves. Also, we'll have a lot of people inside of the security profession doing network pen testing now. If we go back 10 years ago, when I first started inside of the security, I've been in the security for about 13 years now. You go back 10, 12, 13 years ago, most of the people inside of security were doing network packets and playing with network packets, network wrangling, all the fun things we had with network. Now we don't have very many people messing with hardcore network protocols anymore. Most of the people inside of the security community that still are technically involved, because we have a lot that are non-technical security professionals, but most of the ones that are technically involved now are doing web pen testing. There's a huge need for web pen testing. Most of our organizations have moved their business processes and all their applications over to web applications. So now we find the largest percentage of our technical security professionals are doing web pen testing. That's great. The skills work. They've followed the same exact procedure inside of the control center. Most of our control systems now have human-machine interfaces, basically their fancy way of saying user interfaces, that are now web-based. So we need to test a lot of these web interfaces. However, as web pen testers, if you go through and use your normal routines and you kick off your spiders to go start spidering, you kick off your automated vulnerability scanners to find the vulnerabilities so you can start looking and reading those while you're doing your manual pen testing, you'll crash all those systems. Okay? The problem is, on a control system network, the control servers where we have these web interfaces, in order to shut down power for a substation, usually is inside of a web page where we actually have a form where you specify the change that you want to make and you hit the submit. And we all know that we do web pen testing. If you ever run a spider or a vulnerability scanner, the first thing it does is tries to find all the forms and submit every single option of the form. So it's going to try every single option in every single possible way to shut down that substation. Okay, that's probably not a very good thing to do, especially for job security on your shoulders. Another problem we have, if you get outside of the substations, look at manufacturing floors. We have robotic arms manufacturing a large car that's connected to a PLC. And if you're on a web interface and you start sending all these different messages down, and let's say that there's a page that allows you to send a firmware update to that PLC, it's in the middle of building a car. What's going to happen if you try sending a firmware down to it? Or worse, most of these interfaces, just like in any type of a system, they'll usually have 10 or 15 different types of firmware. Let's try sending all 15 types of firmware within about a 2-second period, which is what your scanners, automated scanners, do inside of the web world. Okay? Those systems tend not to like to have that, especially considering the fact that on some of the older ones, and unfortunately on some of the newer ones as well, there's not even enough logic to tell the device not to accept all 15 versions of firmware at the same time. So, yeah, a little bit of error handling problems there. So having this information available, having the tools to do the test, having the methodology, trying to have documentation and guidance for contextual information is really what the goal of SamuraiSTFU is. Okay? When we do penetration testing, I've been specifically working inside of the energy sector and the control systems now for about 5 to 6 years. And over this time period, I've very quickly learned that we have some major problems. Besides the fact that we have some security issues, just like any IT world, any type of IT organization, there are security holes and people can exploit them. Okay? We have these same issues inside of control systems. We need to work with these different types of issues. Inside of the energy sector specifically, and ICS in general, a lot of the security professionals inside of ICS, inside of the energy sector, don't have the technical skills to do penetration testing. There's a lot of firms out there, many of us work for these firms, that do these as services. But unfortunately, most of the consulting firms out there that have very strong penetration testing skills don't have the knowledge and the experience working with control systems. So we have our energy sector and our ICS companies have all these resources they can pull in that have most of the skills needed, but they don't want to bring them in because they don't have that experience. They don't know the contextual information that's so critical to know before you do this work. Because you all have 80 to 90% of all the experience and all the knowledge and all the skills to do the work. You're just missing a lot of the contextual information, a lot of the metadata that kind of goes along with doing the work. So hopefully we can try to overcome that with this distribution. Now, when I created, or as I've been creating SamuraiSTFU, I do have a pre-release copy out. People that took the pen testing SCADA class over the last 2 days here at NOCON do have a pre-release copy. As I was building this pre-release and have been working on this distribution over the last 6 to 8 months, I've really come to the conclusion that my primary audience for this distribution, and as I've been building it, what's in the back of my mind, my primary audience really are these utilities. It's the security teams in the utilities that don't have the tools, they don't have the knowledge, they don't know what they should be doing. That's my primary audience. But my secondary audience is just as important, which really are all the security professionals, all the security researchers out there that don't work inside of ICS, that don't work in the energy sector. Trying to give them some of that contextual knowledge and try to give them something that help get them into this field. Because all of our IT fields need security professionals to do this work. ICS and energy sector is worse off. They need more security professionals. There's a larger deficit to have for people that have this experience. So if there's anything that I can do to try to help the community at large bring more people in to do this work, that's really what I've seen as part of my goal inside of working with the energy utilities. So this distribution that I have, we've talked about some of the goals that I had as I was creating this distribution. Really, I was putting this together. My goal is to put the best cream of the crop, or the best tools for web pen testing in the distribution. Not try to include everything that Samurai WTF has. So Samurai WTF, the web testing framework, is a project I've been running for 4.5 years now. Kevin Johnson and myself started this about 4.5 years ago and been running it, have had 13 or 14 releases of the distribution. I've taken all that knowledge, built this now for SamuraiSTFU for the utilities, basically a sister project. And for some reason, everybody always mixes up the acronyms for my projects. I never understand why. But so I have the best of the web pen testing tools, the best network pen testing tools. So take some of the best ones we have on site of Backtrack, and then take all the different hardware pen testing tools, which, to tell you the truth, there's not really any good distribution out there for all the different hardware pen testing tools. So this is one of the first ones that's trying to bring all these hardware pen testing tools together. And then, as I mentioned, put down documentation, architecture, methodologies, information about the protocols, trying to go through and put different simulated systems on there so that we can play around and understand how the systems work, how the protocols work, and then also have packet captures of the protocol, so you can play with those packet captures. Having different types of data dumps from EEPROMs and bus snooping, so you can go through and practice doing the analysis, trying to extract that information from those data blobs. Now, on the first public release, this is the tools that I will have in the first public release. The people that have the pre-release copy that was released here at the conference, they have a subset of this. They don't quite have all these tools on there yet. They have about 50% of them. But the first public release, which I plan on uploading in about 2 weeks, this is just a list of the major tools that they're going to have. So you can see our good old friends that we always use, our Metasploit and our Nessus and our Nmap, Wireshark, things that we've lived with for years. They're going to be there. We can't do any type of pen testing without them. But then going on to web pen testing, adding things like Burp and Zap and SQL Map and Beef and W3AF, some of the better tools that we have available. And our wireless, we have the traditional Kismet, AirCrack tools that we have out there, having the software for the Ubertooth. If you never play with Ubertooth and Bluetooth, great tool to have. But then also looking at things that are more specific to some of these control system networks. Tools like Killer Bee, which is an attack suite written by Joshua Wright, the same guy that wrote a Sleep for attacking Cisco's Leap protocol. So Killer Bee is an attack protocol for Zigbee networks. Be able to capture Zigbee traffic, inject Zigbee traffic, trying to brute force some of the network keys for Zigbee. Having tools like RFCat has been written by Don Weber and Atlas. A great tool. If you guys like Netcat and play around with Netcat with normal network sockets, go check out RFCat. RFCat tries to be a project very similar to Netcat, but it's for RF. It's supposed a very basic command line interface to it. You pass down the exact specifics for the radio frequency that you're trying to work with, and it tries to go through and just dump all the data off of it for you. Okay, so a great tool. And then we also have tools that have been around for a while that many security professionals have heard about but have never played with, like GNU Radio. Being able to go and work with different types of radio frequencies, trying to decode and demodulate those frequencies, get the information back out, replay some of the RF packets that you captured. And then finally, for the hardware pen test tools, these are ones that many people aren't familiar with. So in capturing and doing the analysis on the embedded boards and doing bus snooping, we have a couple different tools that are available. So the first two are good community tools, GoodFet and the Bus Pirate. Okay, both tools are very, very excellent tools for doing different types of attacks in the embedded space. We have more commercial tools like Total Phase's Aardvark and Beagle, which happen to have some open source libraries, which I'll be including the open source libraries inside of the distribution. So if you have the commercial tools, you can still use those libraries. And then doing other tools like BinDiff that have been around for ages, which is a great tool to use for doing analysis. And then Entropy Graph, which is a newer tool that allows you to go through and take any type of a data source, whether it's something you've dumped from an EEPROM device or something you dumped from a bus or something you've pulled out of the payloads of your network packets, doing an entropy analysis of that payload and trying to identify which parts of the file have higher levels of entropy or more randomness than other parts of the files, which will help you go through and find cryptography keys, which are randomly generated and have higher randomness than the surrounding data, or looking for other types of data and files that may have compression or encryption on them and being able to pull that file out of that larger data blob. So as I mentioned, this distribution is mostly finished. I'll show you a brief walkthrough of it here in just a minute. I'm planning on having this uploaded by March 14th, which is the beginning of Black Hat Europe. This will be available up on SamuraiSTFU.org. Okay, so that's where this distribution will be found. The domain's registered. It does not have any content on the site, so if you visit it now, you won't see anything. But in 2 weeks, you will be able to find the distribution, be able to download it. This is going to be a full open source distribution, freely available. You can grab it, you can download it, you can rebuild it, you can modify it, do whatever you need to do for the distribution. Mailing list around it, so please contribute, join the mailing list, and let me know if you start using these tools, especially in the control systems, what additional tools you would like to see, or if you have other tools that you use in other areas that you think would be beneficial for the control systems. Let me know, and I'll get these different tools added in. Okay, Utilisec, the company that I own and I work for, we're going to be offering commercial support on this. So if there's anybody that is interested in having a commercial support option, so you actually can call somebody up on the phone and actually get some things changed or have some help on it. That will be available through Utilisec. There's not going to be an enterprise or a professional version of SamuraiSTFU. There will be just the open source tool. The support will just be services that are offered around it if anybody's interested. We're also going to be offering public courses. We just finished teaching a 2-day course here at NoleCon. I'm teaching another 2-day class at Black Hat. And then starting in June, the end of May, the beginning of June, the SANS Institute, they're going to love me since I typoed their name in that line right there. Just wanted to call that out so everybody saw that, right? So the SANS Institute is going to be holding another SCADA event in Houston. That will be the first time that I have a 5-day version of the course available that covers the full methodology that I discussed last year at NoleCon. Then I'll be doing the 2-day version back at Black Hat US. Doing the 5-day version at additional SANS events in Baltimore, Seattle, and in December I will be back in Asia teaching that 5-day class in Singapore. But keep your eyes open. This class does have other scheduled events, like I'll be doing at BrewCon in Belgium, I think is still the plan, as well as I have a couple more scheduled throughout the Middle East as well. So lots of options available if you're interested to get some more of the commercial training. If you have any questions, I'll open up for questions in just a minute. But if you have any questions, feel free to drop me a line, send me an email, hit me on one of the social network sites. I don't mind answering those questions at all. And don't forget that even though I do work for Utilisec 100% of the time, I still also am an instructor for SANS. If you have any SANS question, feel free to ask. I usually spend anywhere from 6 to 12 weeks a year working or teaching classes for SANS. I teach their web pen testing class. I also teach their one of their mobile classes, mobile security. And then also I do a brand new one that we're just coming up, which is a pen testing with Python. So a 5-day class which is doing nothing but writing Python tools to help enable and expand your capabilities in doing penetration tests. So SANS has several events coming up here in India. We have our Delhi event at the beginning of April. We have our Bangalore event at the end of April. And we have one in Mumbai in July. So with that, let me go ahead and open up to questions. Does anybody have any questions about the distribution or about any of the information that I presented today? Yes? Yeah, let's go up here front, front first.
Thanks, Justin, for a wonderful presentation. Inherently, we know that SCADA networks and tools were never built with security in mind because they have been legacy systems. Do you see, after the recent attacks and other stuff, you know the history over the last 1 year, how they've been exploited, Flame, Duku, and other stuff. Do you see a trend with the SCADA manufacturers, the software makers? Do you see a trend towards improving security, or is it the same old lethargic attitude?
No, I definitely do see a trend. If we don't just, even not just the 1 year, if you go back, it was 2 years ago that Stuxnet was released. And you go back further from that, and we had a lot of different types of discussions and presentations on SCADA. I mean, you can go back to the early 2000s and find security presentations on SCADA back at DEF CON and Black Hat. So I think that we finally have hit that critical mass. We've been talking about it for years. The security industry has starting to gain more and more interest inside of this area. We're seeing more presentations. And I think finally, with the realization of Stuxnets and some of the major compromises that we had, especially with Saudi Aramco this last summer, that many of the manufacturers, as well as the asset owners, the people buying the equipment from the vendors, I think that they are all taking it very seriously. We look at any of the large manufacturers like ABB and Siemens, they are taking it very seriously. They're building their security teams. They're training. I've personally trained teams from Siemens and some of these other companies that have come trying to figure out what can we do to improve our security of these systems. So they are taking it seriously, but we have to remember that it's a long road. How long have we been taking it seriously inside of IT? Security never ends. It's going to go on, and all we do is we keep on trying to make it better and better. So at least I think they're on the wagon now. Before, they didn't even really know that the wagon or the train existed. So I think they're now on board, and they're trying to catch up with the rest of IT.
Thanks. And just a follow-up question. Are there any security frameworks for SCADA that you're aware of?
So Security frameworks in which manner?
I'm talking, say, could there be like something like an ISO? I'm just being
So more like
generic.
a standard or something that you
Yeah,
should try to build your security against?
yeah, yeah.
Yes, there are a couple that are out there. Back in the United States, that's where I'm most familiar with what's commonly available. Back in the United States, the NIST, the National Institute of Standards and Technology, they have had out for a number of years some recommendations for control systems. Department of Homeland Security also has out some recommendations for control systems. So there's lots of different pieces of guidance that are out there. Most of it is not regulatory in nature, so you can't say you must meet this or you must follow this, because most of it is guidance level, saying this is how we should be doing things, and some of those shoulds are things that are still 10 years out. But yeah, so there's a lot of guidance. If you want some more, just drop me an email and I can point you to something more specific that might meet your needs.
Sure. Thanks, Justin.
Sure.
Hi, this is Kush here. The first question, I actually have a twofold question. The first thing being that you see state-sponsored attacks like Stuxnet and Flame and Duku. Last week, some information was uncovered by Symantec pointing towards Stuxnet being developed since 2005. So if you have state-sponsored attacks, why don't we have state-sponsored defense? That's a serious question.
So if we have state-sponsored attacks, why don't we have state-sponsored defense? I think we do have state-sponsored defense, but I think it's something harder to do, because the problem is, to do attacks, you don't have to be an asset owner to do attacks. So it's easy for nation states to enter into doing different types of attacks, or at least preparing for that need for be able to do the attacks. However, once we start looking at defense, you must have a presence at that asset owner, or must somewhere be in the line between the attackers and the asset owners, which, in order to have any capabilities of defending. And the problem is, for most countries around the world, most countries, the government and the people that chose that government often tell the government they don't want the government to be in their defense. They don't want them to have control over the network because of other business concerns, privacy concerns, economic concerns. So I think that's the biggest reason why you don't see more of a proactive defense. However, I think most governments are doing as much as they can. You'll see lots of standards works and guidance going on inside of the United States, a lot going on in India, a lot going on in Asia. I mean, there's a lot of discussions. A lot of governments are funding different initiatives to try to provide guidance to the asset owners and to the vendors. A lot of them are providing different types of grants and opportunities for the vendors to improve their security. So I think it's going on. It's just not the active defense, because they don't own the assets to actively defend. Does that make sense?
Yeah, actually. And my second question was, as a beginner, someone who's not too familiar with SCADA systems, where would you suggest a point of beginning? Because, I mean, if you're getting into networking, even for something like simply networking, not just security testing, you have packet tracer and all those tools to simulate such systems. And since states can't afford it, let alone individuals, is there anything that you could suggest for beginners?
Can you repeat that question a different way? I'm having a hard time understanding what specifically.
For example, if you want to simulate network tests or even network configurations, you can use tools like packet tracer to simulate network management. So if you want to simulate something for SCADA systems, is there something beginner friendly that you would suggest?
So more about simulation, other ways to be able to do simulation.
Yeah.
You can do that, but if you're doing things like only simulating the network connections and simulating things like the network tracer, that's only one very small piece of the attack surface, because usually it's going to be the implementation of those protocols on each of those endpoints where the vulnerabilities lie, or inside of the embedded components on those systems. And that becomes a lot harder to simulate. So when we work with simulators, generally in the security field, especially when we're talking about penetration testing, most of the simulators I'm interested in is to help myself and other security professionals gain knowledge in working with that protocol or working with similar devices. But when we talk about penetration testing, I personally don't think that simulation and testing against simulated devices will ever be beneficial or a measurement of risk through a penetration test.
But isn't that the closest an individual can get?
No, it's not it's not the closest thing we can get. Testing the real devices is I think, better if we can get those real devices. But that requires the cooperation with the asset owners. A lot of the software and tools and devices are available. Most of it is very expensive and hard to get your hands on. But there are pieces out there. Go around and look at any of the announcements for when people release bugs and vulnerabilities and 0 days on the SCADA equipment. Most of that equipment is either freely available for downloads as demo copies, or possibly easily found on sites like eBay to find used, fairly inexpensive versions of it. So,
Thank you.
Hi there. I just want to ask, like, in embedded hardware testing, these days they are migrating to SOCs.
Sorry, I interrupted. Go ahead.
Sorry, we are migrating to system on chip, where we are using CAN protocol, ARM7 protocols and all. Now, do you have any tools to test those using the JTAG interfaces or anything like that in your framework?
So the question is if you're going up against a system on a chip, are there any tools in the framework to do the test specifically against system on a chip architectures?
Yeah, because as he said, simulation, yes, we can't cover everything. But most of the products, at one point or the other, they're using the SOCs these days.
Yeah.
So for those SOC testing, is there any tools in your framework?
I don't currently have any tools in the framework to work directly with system on a chip, because usually when you're working at that level and you're trying to attack the components of a single chip, then you're going to have to be decapping it, taking it under an electron microscope, taking imaging of it, and then using some type of software or decoder to try to take that image back to the actual binary bits saved on that system on a chip. So tools like that, no, I do not have. But for JTAG interfaces, I do have some of the JTAG tools on there, specifically like tools for TI. I have some of the TI JTAG interface protocols in there. Anything that's supported by the Bus Pirate, it supports a number of JTAG interfaces, so there's options there. There's also the GoodFET, which supports a large number of JTAG interfaces, which are also installed on the distribution. So JTAG, yes. Decapping of system on a chip and microelectronics to reverse, no, I don't have any of that tools on there yet.
No, that's the one I was asking about because of CAN protocol and ARM bus protocol. Thanks a lot.
Yeah, CAN bus, no, I don't have anything for CAN bus, but I do have some other things for some of the other systems. So.
Thank you.
Another question?
Okay, one final question.
First of all, thanks for the presentation. I just need to ask you, we have these SCADA systems in our area of work. Now, I would request you when you upload your tool, if a grid would have multi-legacy SCADA systems, distribution, and a lot of these legacy systems have closed development in that all protocols are proprietary. Now, in that case, to use a generic kind of a tool, so a lot of customization would be required on site. And when you actually go ahead and do, a couple of SCADAs, you still cannot get an assurance for the entire grid because you're using certain old SCADAs also. So, how do we go about it? And if you could put a case study from your experience along with your tool, it would help us to engineer some kind of a testing framework for our systems.
Okay. So the question is more around how are we working with all these proprietary systems? Because most of the tools that we have in IT work with very common known systems, but they don't work with these proprietary systems. One of the big goals of SamuraiSTFU, as well as the methodology, if you go in and read the methodology that I put together, is it really tries to focus on the abstract process of penetration testing. It takes penetration testing and breaks it into 56 different tasks. And it tries to focus on working with a lot of these custom or proprietary protocols. We don't make the assumption that you will have tools that work with all the protocols. In fact, most of the time you don't. For instance, the very first system that I worked on about 5 or 6 years ago was a smart meter system that had a proprietary 900 megahertz communication channel. Okay, and so we needed to try to work with this, but we didn't have any tools that supported it. We didn't have dissectors in Wireshark. We didn't even have a way to capture the PCAP to get it into Wireshark in the first place. So a lot of the technologies and the process and the methodology and the tools try to talk about this and try to address this. Like, there's more than one way to capture things than off of an Ethernet. We can try to go to the head end and capture it before it hits the head end or the control server to see the data that way. But if I need to capture it off the wire, often the RF chip is having that data sent to it from the microcontroller, and if I can do bus snooping, then I can capture that communication channel off there. So that's a way to at least capture that data. And then trying to work with the proprietary protocol, if it's a pseudo-proprietary protocol, more of a standards-based but a niche standard, then you might be able to get a copy of the standard and work with it. If not, for instance, a lot of the field technician interfaces, you'll have like a serial interface on one of the field devices, and it has a proprietary interface on that. Often you just go through the normal process of reverse engineering. I find a way to be able to capture and analyze that information, and then I go to the control system server or the interface, whatever, somehow to be able to manipulate the traffic, and I send a request or use a function that I know what function I used, and I try to capture just that one single request that I made. So using that information, I look at the data and try to understand what did I just do in that interface came through inside of this message, because I know I just did something, I know it came in this message. Just use the process of reverse engineering to try to figure out exactly what bits represent what types of information. We rarely will reverse engineer everything inside of these types of work. Just like all pen testers, we're very limited on our time. You do a web pen test, you're not reverse engineering all the code, all the functionality. You're looking for the vulnerabilities. We reverse engineer just enough of the protocols to be able to do the fuzzing, to find the vulnerabilities. So does that help understand a little bit more about what proprietary nature of some of the protocols? And so what's the time frame for the testing? It depends on the type of components. Most of the, if you look at doing embedded boards, if I'm only doing a testing on the embedded boards, you're probably looking at doing maybe 1 to 2 weeks on doing just the embedded boards. If you're trying to reverse the wireless protocol, maybe 1 to 2 weeks on doing the wireless protocol. 1 if there's no frequency hopping, 2 or more if there's frequency hopping involved. If you look through the methodology, the methodology will go through and each of the tasks have a recommended level of effort. And I use the generic terms low to represent up to 4 hours worth of effort, medium 4 to 16 hours, high 16 to 40 hours, and very high is anything over 40 hours. So each task usually has some type of a recommended level of effort tied to each task. Okay? And that's it. If we have any more questions, I'll be more than happy to answer them. I'll go ahead and I'll step back out in the hall, probably just right here by this door, and I'll answer any other questions that people have. Other than that, enjoy the rest of your conference, and thanks for listening.